Welcome back, everybody. In our third video, we're going to use our trigonometric functions, sine, cosine, and tangent again. But this time, instead of solving for a missing side, we're going to be solving for an unknown angle. And one of the important things that we need to remember with sine, cosine, and tangent is that they are what we call functions. Alright? And functions have this special thing. It's not like this is multiplication or division or addition or subtraction. This thing is doing something to that angle, that number theta. So sine is doing something to theta, and then the answer that it gives us on the other side over here is the ratio of the opposite side of the hypotenuse. Now that sounds all complicated, but here's the idea. Whatever it does to theta, if we want to solve for theta or solve for our unknown angle, alright? So if this is our unknown value, then we're going to need to undo it. And the way that we undo it is with what we call an inverse function. So we can't just divide by sine or divide by cosine or divide by tangent, because that's not what they are. This isn't multiplication or division. This is a function. So the way we undo a function is with its inverse function, and each one of these has an inverse function. So the inverse of sine, or to unsine in a way, we write it like this. This is inverse sine. Cosine has one, it's inverse cosine. Tangent has one, it's inverse tangent. And so if we want to undo sine, cosine, or tangent, then we use their inverse functions. If you look on your calculator, right above sine, cosine, and tangent, you'll see there are options for the inverse functions. Sine to the negative first power, cosine to the negative first, tangent to the negative first. So to do that on our calculators here, all we really need to do is hit either a shift or a second, in this case on my calculator, and it'll give us an inverse function instead. So we're going to see how these inverse functions work so that we can solve for angles. That is the only time that we are going to use an inverse function. Alright? So here are three examples where we're going to be solving for angles. You're going to notice that we're in each one of these situations given two sides, and my unknown is an angle. In this case it's angle A. In our second example, again, angle A is my unknown, and then in the third part, right, we have two known sides and an unknown, angle B. So B and A, capital A and capital B, right, those are angles. That's what we're solving for. And we're given two sides. So anytime we want to solve for an angle, we're going to use those inverse functions to help us out. So let's start with example number 1. Alright, so we're going to draw our triangle. We have sides A is equal to 3 and C is equal to 4. Alright, and we're going to be looking for angle A. Okay. So here's my triangle, side C, side A, side B, right? This is angle B up here, this is angle A right over here. Remember, we said A is equal to 3, C is equal to 4. So the value for A is 3, the value for C is 4. We're looking for the value of angle A. So this is my unknown value. And that's different. In all the other examples, we knew the angle and we put it right into that function and we punched it in the calculator. But now we're trying to find that angle. So I'm going to look at just those three things, my two givens and my one unknown. So I'm going to ignore angle B and side B for this problem. And I'm going to look at the two sides that I have. So we're looking for angle A. Side A is opposite. Side C is always the hypotenuse. So since I have opposite and hypotenuse, I'm going to be using the sine function, because sine is opposite over hypotenuse. So I'm going to go ahead and I'm going to write that. So sine of theta is the opposite side over the hypotenuse side. In this example, the theta that we're looking for is angle A, right up here. So that's the angle, so I'm going to use sine A. My opposite side is side A. My hypotenuse is side C, so this is the equation that I'm going to use. Now when I do my substitution step, this is where we're going to see a difference from the previous problems. So now I have sine, and since I don't know what A is, that's my unknown, I'm going to leave it in the equation. And side A is 3, and side C is 4. So in this case, the sine of angle A is equal to 3/4. Well, if I want to get rid of this sine, because I have to peel that layer off of the outside, I have to get rid of it. Well, I can't divide by sine. Instead, what I'm going to do is I'm going to use the inverse function. So I'm going to take the function on both sides. I'm going to use the inverse of it. So I'm going to write sine inverse, and then I'm going to start a set of parentheses. And inside of this I have the sine of angle A. And anything that I do to one side of the equation I have to do to the other side. So I'm going to take the inverse sine of the right side as well and put that 3/4 into those brackets. On the left side over here, this inverse sine is going to cancel this sine right here. So the inverse sine of sine just causes them both to cancel out, and on the left side we're just left with angle A. On the right side we still have the inverse sine of 3/4, and that's how we're going to get the value for angle A. We're going to do inverse sine of 3/4. So over here on my calculator, alright, I'm going to hit second, and then sine, and that's going to give me the inverse sine. And inside of that I'm going to do 3 divided by 4. The answer that I get here is angle A. Alright, because A is equal to the inverse sine of 3/4. That equals 48.59 degrees. And so that's how we use inverse functions to cancel out a function so that we can solve for angles. Alright? We're going to do the second example. We're going to see the same kind of pattern, alright, where we're going to be solving for the angle. In this case, we have side A is 3, side B is 4, and we're going to look for angle A. Alright? So we'll draw our picture. A, B, C, angle B, angle A. We know that side A is equal to 3 and side B is equal to 4. We're looking for our unknown angle A. So A equals question mark. So I'm going to ignore angle B, and I'm going to ignore the hypotenuse C. So side A is opposite angle A, side B is adjacent to angle A. So I'm going to use the function that uses opposite and adjacent. That's going to be tangent. So tangent of theta is equal to opposite over adjacent. In this example, theta is angle A. That's my unknown. My opposite side is side A. My adjacent side is side B. I'm going to do my substitution. So I have the tangent of angle A is equal to side A over side B, which is 4. Well, now this looks like the same thing we had on the last example, but here's the thing. We have a different function. Now this is tangent. So for us to get at this A that's trapped inside of that function, we're going to need to use the inverse of that function. So to get rid of tangent, we're going to use the inverse tangent. And anything I do to the left side, I have to do to the right side as well. That keeps it equal. And so now I'm going to take the inverse tangent of 3/4. Over here on the left side, tangent inverse cancels with tangent, leaves me with just angle A is equal to that inverse tangent of 3/4. We can go ahead and we can plug that in. So I hit second tangent 3/4. Oops. 3 divided by 4. And now I get an answer of 36.87 degrees. Good stuff, right? So inverse functions help to cancel out, all right, the function itself so that we can solve for the variable, the unknown that's on the inside. This is the only time we use inverse functions, is when we need to get at what's inside of that function. All right, good luck on your homework, everybody.